states that provided elastic limit has not been exceeded, the applied force is directly proportional to what? Extension. Now let's look at, let me just create a picture in your mind. We have a spring. This is a spring I have here. Originally, this is the length. This is the original. I can call it from this point. Say, okay, from here, let's just see from there. Okay, we start from here down here as the original O. Now, when we add the load on it, when we apply a force on it, we notice there's a kind of extension. That's the load limit. So from this point down, we have the E, which is the extension. So according to Hooke's law says that this thing that happens here, this is our force now, F. The load has a force as a result of gravity. Now, this is the load here, the force that is acting on it. According to Hooke's law, it said that this force is directly proportional to what? Extension. As the force, that means as the force increases, the extension will also increase, as long as it has not exceeded the elastic limits. The point when once it's exceeded, remember, once it's exceeded the elastic limit, it can never be elastic again anymore. The elastic property will disappear. So now, if looking at this, if we apply the constant, it means that K is equal to E. Of force is equal to K multiplied by E, where E is our extension, as we have already stated. Pay attention to this extension, and then K is what we call stiffness or elastic, or we say what? Elastic constant. We say elastic constant. So now we have this as our relationship here. This is our relationship. So based on this now, we can use this to solve some problem. We're going to be looking at some example questions that will help us understand how it is being applied in the world of science. So this is the question. We have a force of 8 Newton stretches an elastic spring by 20 cm. Find the elastic constant of the spring, and what will be its extension if a force of 12 Newton is applied. Now, this is what we are going to do. To solve this thing, remember the law, Hooke's law, that says that this our K, our force we know is in Newton, and then K is a Newton per meter, and our extension is what? In meter. So, but this thing, what we have, the question there is 20 cm, so we need to convert it in order to apply this law to make it effective. So now, since we have in cm, means that 20 divided by 100. We are divided by 100 because we want to convert to what? Meter. So what we have here will be 0.2 meter. So this one is done. We have it. Knows very well. So now we're going to be substituting each of the values. Remember, our force, the initial force we have is 8 Newton, and then our extension is now 0.2 meter. Now we're going to find a constant. Constant is what we don't know here. To get this constant, we substitute. When we substitute, we have 8 Newton equal to K, which is the constant, elastic constant, and then E, which is times 0.2 meter. So if we make K the subject of the formula, K will then be will then be 8 over 0.2. That will give us, should be 40 Newton meter. That is what we have. Now with this note, we have the constant. It's still the same elastic spring. So we said that what will happen? We want to find out the extension when the force is now 12 Newton. To get the force when the force will happen when the force is 12 Newton. So let's see what we do. We have a 12 Newton this time. Force is equal to what? 12 Newton. And our extension is unknown. We don't have the extension. This is the one we are looking for, question mark. And then our K this time is what? 40 Newton meter. Newton per meter. Sorry. Newton per meter. Newton per meter. That is what we have. It's not just Newton meter. Not very, it's Newton per meter. So we are going to substitute. If we substitute for the force, remember our law. We have KE. Then force is what? 40 equal to K. Now K is what? 40 and E is unknown. Making E the subject of the formula, we have 12 over what? 40. 12 over 40. I believe we are following. 12 over 40. I think I hope my calculator will work. What is wrong? Hey, it's amazing. Amazing calculator. Divide by 40. We have the extension to be what? Our extension this time is now 0.3 meter. That is our extension. Or we can convert it to cm. We have what? 30 multiplied by 100. We have 30 cm. So that's what we have. So we're going to be looking at another question. We're going to be seeing another question again as something that will be a bit different from what we have here. So here it said that a force of 20 newtons stretched an elastic material by 300 millimeter. What additional force will stretch the material by what? 350 millimeter. Assuming the elastic limit has not exceeded. When elastic limit has not exceeded, it means that the Hooke's law is obeyed, which is Ke. Force is equal to Ke. So the first one we have, they said that the first force is that this is millimeter. And this time around, we have our extension to be was 300 millimeter. And to get this one, we need to convert it towards meters. To convert it to meters means that 300 divided by 1000. That will give us 0.3 meter. That is what we are going to get. So E now is 0.3 meter. So what next? Our extension is what we don't know. First, we need to get this extension. Question mark. I put question marks here. So our force here is what? 20 Newton. So what are we going to do? What are we going to do? We are going to use, now we apply this, we use this, substitute each of them. We substitute. When we substitute, you have force to be 20 Newton equal to K, which we don't know, and then our 0.3. So when we cross over, K is equal to 20 over 0.3. So by dividing this, if we divide 20 divided by 0.3, we have let's say approximately 66.7 Newton per meter. That is what we have. Now we have our constant, the elastic constant. Now we can go ahead and get what the force will be when its material is stretched by what? 350 millimeter. So what we are going to do next is, I think I can clean here. So we have our extension to be what? 350 millimeter this time, which will also be 350 divided by 1000. When we do that, 350 divided by 1000, 350 divided by 1000 to give us 0.35 meter. So our K this time is what? 6.7 Newton per meter. So we substitute. Our force is what we don't know. We don't know the force. Then force will be equal to 66.7 times 0.35. 0.35. When we multiply through times 0.7, we have what we have is equal to 3 points. We can say approximately okay. Yes, approximately we can make it approximately 4 Newton. Or the nearest whole number will have 23 Newton. So this is how to handle this question. So if you have been able to get to this point, I have to say that I want to thank you so much, and you are very, very amazing. Thank you for coming this far. And if you have any question, you leave it in the comment section. And then remember to share and like. Thank you.